with solving equations, give you a couple more examples. These are a little more in depth than the ones from the first day. So solving for x, here's our equation. I'm going to reiterate something I've said a few times. Anytime you solve an equation, no matter what level you get to, up to differential equations, always use order of operations backwards. All right, so parentheses usually come first. If we're solving an equation, parentheses have to come last. So this x divided by 3 in parentheses is got to be the last thing we do. We'll start with addition, subtraction, go with multiplication, division, then powers, then parentheses last. So no addition or subtraction, but we can divide out this 2. So let's go ahead and take care of that. So sine of x over 3 is 1/2. Now we can do arc sine, but we really want to know everywhere sine could be 1/2. So I'm going to recommend that we do the unit circle idea. Now sine is 1/2 at pi over 6, and again at 5 pi over 6. So that means that x over 3, it could be pi over 6, or it could be 5 pi over 6. Now this did say solve for x. It didn't say just from 0 to 2 pi. So we did all possible solutions. So these are not equally spaced out. The next time you'll get a solution that's coterminal with this, it'll be one full lap around, so plus 2 pi in. And same thing for 5 pi over 6. You'll need to go a full lap around to get another coterminal angle. So plus 2 pi into both of those. Now again, I took the sine of 1/2 to get an actual angle measurement. That's why that's no longer there. Left with x over 3. So the last thing now is to go ahead and multiply everything by 3 on both sides. So let's do that here. A little dividing wall up there. And just remember, I'm distributing on the right side of both equations. So wrap it up. X is going to be 3 pi over 6, so pi over 2, plus 6 pi in. And over here, 3 times 5, so 15 pi over 6, we'll reduce that, it's 5 pi over 2, plus 6 pi in. And just something to kind of be thinking about, it's sine of x over 3. So the frequency is going to be 1/3 what we normally have. Or think about that with period, it's going to be 3 times longer. So one wave, typically from 0 to 2 pi, now it's going to be from 0 to 6 pi. It's going to be really stretched out. So things are happening 3 times slower. That's where you're getting the 6 pi in. So that seems to kind of make sense with everything we know about the way the graph should look. So that's kind of a little check you can use as you're going here. For this example, we're finding zeros. So I went ahead and just said f of x is 0 because I want to see where it crosses the x-axis. So again, back to PEMDAS. We always want to go with addition, subtraction first, work our way up the chain. Parentheses will have to come last. So this right here will be the last thing we deal with. So the first thing we could do is to add 1 to both sides. And I'll go ahead and write out what we have at that stage. The next thing would be to divide by 4 on both sides. So now 1/4 is sine squared of pi x over 2. So now I'm up to, I want to take a square root. I want to get rid of this sine squared. So that's going to be plus or minus 1/2. Don't forget that when you take a square root, you got a plus or minus. This is why I've made an emphasis of making sure you reduce your fractions. I want you all thinking about anytime you can reduce a fraction, go ahead and do it. So sine is all that's left now, sine of pi x over 2. All right, so now we're going to take the sine, or find out where sine is plus or minus 1/2. So I'm going to go back to drawing a unit circle. Well, here's a positive 1/2, here's negative 1/2. So think about all the places where sine could be that. That's pi over 6, that's 5 pi over 6, that's 7 pi over 6, and 11 pi over 6. Those are all the places sine can be plus or minus 1/2. So let's go ahead and see if we can come up with some kind of pattern for that. Pi x over 2, because I've now taken sine of this, or taken arc sine. Well, pi over 6 and half a circle gets me to here. 5 pi over 6 plus half a circle gets to here. So that'll eliminate a little bit of work. I can say pi over 6 plus pi n. instead of doing 4 separate problems here, it just looks nicer and it's quicker, it's more efficient. So there's really no reason to do 4 separate problems here. Pi over 6 and half a circle, so pi radians later is this same angle right there. So that's the way I'm going to work that part. And also pi x over 2 would be 5 pi over 6 plus a half a circle. So 5 pi over 6 plus pi n. Now let's wrap that up. So to finish this up, I'm going to multiply by 2 over pi. And that's distributed on the right side. So the pi's would cancel out here, and that's going to be 1/3. This is kind of weird, but radians don't necessarily have to have pi. A lot of times we have pi with those. Remember, 1 radian is the radius stretched across the circumference of the circle. It's about 57 point something degrees. But 1 radian doesn't have the term pi in it. So radians don't have to have pi. We get kind of used to seeing them that way, but radians can just be decimal numbers. They don't need to have pi associated with them. So this is 1/3 of a radian plus, and that pi would go away, and that would be 2n. Over here, same deal. Let's multiply by 2 over pi. Both sides. Think of it as distributing. It's going to go away here. All right, 2 over 6 is going to be 1/3. The pi's go away, so 5/3. Plus, these pi's cancel out. That's 2n. So there you go. You get 1/3 plus 2n and 5/3 plus 2n.